Okay, in last chapter, we have discussed central limit theorem that we will be using in our chapter 8. The reason we discussed about normal distribution, central limit theorem, and now we are going to discuss about confidence interval or estimation. These things are all connected to each other. Why it is important for us to study about normal distributions, why it is important for us to study about central limit theorem, and why it is important for us to now we are using inferential statistics. The reason is we want to make predictions about the population by using the sample spaces. For instance, if I say that in Mid-Michigan College, let's say in my class, if 1/6 of proportion of the number of students in my class has the has the blonde hair, so does it mean that 1/6 students in overall Mid-Michigan College has blonde hair? We don't know. It might be possible or it might not be possible. So how good our estimation it is, how we can predict about the population by using sample spaces. So this is what we will be discussing in today's topic, which is confidence interval. Or we can also call it as an estimation, how estimatedly we are correct or we are accurate to find the values for about the population. The overall thing about statistics is that we want to predict something for large population, for overall things like for instance in COVID-19, let's say people were affected by COVID and how likely it will be this situation will be overcome in United States by over in the end of 2021, or what will be forecasting of the dollars in future in 2022. So the statistics overall we use for forecasting. So for predicting something about the future for the large populations for overall for entire population. So this is why we need to study statistics. The reason we studied normally distribution, the normal distribution is important because when we create, most of the time it happens when we take the large sample size or the overall population and we find something, or let's say anything about the population or the sample spaces. Let's say we are talking about the mean. Let's say what is the average height of the people in the Michigan, or the average height of the people in let's say Mississippi, or average height of the people in Arkansas, different state. So how do we can predict it for the overall population? So this is why it is important. So if we discuss about the mean of the sample spaces, and when we create their sampling distribution, so that is normally distributed. So it often happen that we have when we make the sampling distribution of any sample space, so it will be normally distributed if we take a very large number of sample spaces. So this is why normal distribution is important. So when we discussed about normal distributions, then it is important for us to study the central limit theorem, because we can utilize central limit theorem for estimation about large things. Like in confidence interval, today's our topic is confidence interval. So today we will be talking about that how we can estimate a parameter for population by using the sample statistic. So most often we discussed about averages and proportion in this chapter. So let's say for sure, it is confidence interval. We are estimating the value for the population by using sample spaces. So this is why it is called inferential statistics, because we are interpreting something about the population by using sample spaces. So we take the sample space and we will use one sample space to predict about the entire population. So we will project the results of a sample to the entire population. This is what we will be doing in confidence interval. So in our chapter, this thing, today we will be talking about only two things. In overall of this chapter, we have two things to discuss about. One is averages and other is proportions. So for instance, in averages, we will find the average of the sample, and we will be estimating the average of the population. And in proportion, we will take the proportion of one sample from the entire population, and we will be projecting it to the proportion of the population. Like I gave you an example of the blunt hair of 1/6 number of students in my class. So is it important? For instance, let's say 1/6 number of students in my class have their height 5 foot and 2 inches. So does it mean that 1/6 number of students of entire mid Michigan has the height of 5 foot and 2 inch? So it might be, it might not be. How good our accuracy, how good our estimation is, this is what we will be discussing about in today's lecture. So for confidence intervals, we need to have few things. So it means finding the confidence interval, because first thing we will be discussing about here proportions. We will be estimating the value of the population proportion from a sample proportion. So we need few things. First of all, we will take random samples, because without random samples, we cannot interpret about something about our population. So this is why we need random samples of different sizes, of same sizes, but many different samples of the same size for the entire population we will be using. Another thing is that, for instance, here, we will be using, we will be actually employing the binomial distribution conditions, because here in today's lecture, what we are going to do, we will be employing binomial distribution for our, the reason is why we are discussing about binomial distributions, because we will be employing large number of rules. So in large sample methods, what we have done, that we will assume that the normal curve is a good approximation for the to the binomial distribution of the entire curve. The reason is, when we have a samples, we have a very big sample size, and when we have to make um, the sampling distribution, and here the sampling distributions we will be making by binomial distribution. And this is why we have to utilize binomial distributions for the sampling distribution to create the normal curve. Because if we have a normal curve, then we can use the same conditions for finding the confidence intervals, or for finding the area and probability, the same thing that you have done before. So we will be utilizing binomial distribution conditions in order to find the population proportion. So in binomial distributions, we know if we are discussing about binomial distributions, so the number of trials has to be fixed. And in binomial distributions, the trials are independent. So it means one trial is not depending on the other. And there are only two outcomes for the binomial distributions, because bi means two. So we have only two outcomes. One is success and other is failure. So for sufficiently large number of size of population, it is important that it will satisfy NP is greater or equal to 1 and NQ is greater than 5. N is our sample size and P is because binomial distribution we discussed, if you remember, we discussed about success or failure. So P is the probability of success of one event in a single trial, and Q is the probability of failure in one single trial. So it will satisfy these two conditions. Then we can utilize the central limit theorem for finding the population proportion by using the estimated value. So what is point estimate? Point estimate, so remember one thing, that we are taking sample spaces. By taking one estimating value of the sample space, we are going to project it to the point of the point of the population. We are estimating the value of the population. So point estimate is the numerical value for a sample that is giving you, or that is the best, giving you the best estimating value for the population. So it means it is that numerical value that is going, that we are going to use for the best approximate value for the population. So this is the numerical value that we will be using to find the estimated value for the population. So this is what it means. We will discuss it in a bit, in a while, that what is point estimation in our problems. So point estimate is a single value that we are going to use to approximate the value of the population. For instance, the sample that has a mean weight of 172 pounds. So we estimate that the population has a mean weight of 172 pounds. Like for instance, let's say the average height in my class is 5 foot 2 inches. So does it mean that the average height of entire mid Michigan is 5 foot 2 inch? So this means I am using the value of my class to predict the value of the population of the mid Michigan. So using one sample, I am going to estimate the value of the entire population. So if the mean weight of one sample from the entire population has weight 172 pounds, so we are going to estimate that, okay, if for sample space the mean weight is 172, so for entire population the average weight will be 172 pounds as well. So this is our estimating value for the population in this case. There are some symbols that is important for us to know, that which symbols we are going to use. P is for population proportion of success. P cap or P hat is the sample proportion of success. P is the population proportion. If we are using P hat, that will be using for sample proportion of success. So remember, P is for success and Q is for failure. If we are using P, then that is the population proportion of success. If you're using P hat, that means it is sample proportion of success. And for sample proportion of success, we we have the formula by using the classical probability. We will be writing it down like X by N. X is the number of times the success is occurred in our total sample space divided by the number of sample space. So this is how we will be calculating the value of the P cap. Q cap is a sample proportion of failure. So we know P plus Q, like success plus failure is equal to 1, because overall entire space is equal to the 1. The overall area is equal to 1. So if you have to calculate the failure, the sample proportion of failure, so this will be 1 minus P hat. So in this case, the estimated value for P is P cap. So P cap is our point estimate for the population proportion, for the population value, because we are predicting something about the population. Here we are, the topic is for, in today's topic we're discussing about only proportion, population proportion, by using the sample proportion. So sample proportion is our point estimate and P is our population proportion here. So P hat is the point estimate for P. So what is the drawback for point estimate? For instance, in this example here, I'm giving you one of the examples. Let's suppose that the sample of 800 students are selected at random from Mid-Michigan College, and they are given a shot to prevent from certain type of flu. They are exposed to the flu and 600 of them do not get the flu. So P hat is So what does it mean? Let me discuss something about it. In we are taking in Mid Michigan College, we have, let's say, 20,000 students overall. And from those 20,000 students, I am taking only 800 students and I'm giving them the flu shot. Sorry, the shot to, it's a shot to prevent from the flu. I'm giving them a shot. Like vaccination, we are taking by to prevent for COVID-19. So, and they are exposed to the flu, and 600 out of 800 students are, they did not get flu. And 200, it means 200 students got the flu even after having a shot, but 600 did not get. So, what is the success here? What is the success in our case? That that the students who do not get flu, this is our success. So how many number of students did not get flu after getting a shot? So 600 of people, 600 number of students did not get the flu shot, did not get the flu after having a shot. So the success is, what is the proportion of our success in this sample space, which is 600 by 800. So if you calculate it, it will be giving you 0.75. It means 75% of the students over 800, out of 800 students, they did not get um, the flu. So what is the probability P that the shot will be successful for any single student selected at random from the entire Mid Michigan College? So what is the probability that any student, if I am going to take from Mid Michigan, that who is not getting a flu after getting the flu shot? So if P is 0.85, let's say we are taking that, we are thinking that population proportion, the number of students who are not getting flu after getting a shot is 0.85. So is it okay? So it means our estimating value is 0.75 that we took from out of 8 number of students. So does it mean that if the success rate for 800 number of students is 0.75, then 0.85 will be the best estimation for the entire number of students in Mid Michigan College? Is it the best approximation? How do we know that it has to be near to this value? Because when we, let's say we have a survey, does it mean that everyone will be satisfied for one person? For instance, if you are asked for the feedback for any app, some students, some people say, okay, this app I like. Some say we are satisfied. Some say we are strongly agree with that. Some say we do not agree. So the satisfaction will not be 100%. So what is the average proportion that people are satisfied with that using that applications, or what is the percentage that people are not satisfied? So we cannot have 100% of people who are satisfied with this thing. So this is why um, we use the point estimation. So point estimation, how accurate the value it is for, how accurate this value is for the Mid Michigan, for entire Mid Michigan College, that if we take any random number of students, then 0.85 is the best approximation, is the best approximation for Mid Michigan College. So should it be within the margin of zero point 0.1 or 0.05 from 0.75? So how accurate is this value? We have to calculate how best approximation we are having for the entire population. If this is my point estimate, how best is our estimation for the entire population? This is what we need to know. And how best it is, this is why we need to find the interval for which the population proportion will be consisting in that. So hopefully I have discussed it properly. If you have some problem, please give me a feedback, or I can discuss it later. So the summary is that the point estimate, we are estimating one value for sample, and we are projecting this value to the entire population. We are estimating the value of the population by using the point estimation for the sample space. This is what it means. So how best is our value for the entire population? This is why we need the range of numbers in between that value is occurred. So for instance, 0.75 is the point estimated value for Mid-Michigan College. So how accurate, what is the probability that for entire Mid-Michigan, it will be 0.75 or it will be 0.755 or it will be 0.65? How accurate will the value it will be? What will be the range that for the population proportion will be occurred in that range? So we need to find the range of numbers in which the value will be occurred. For instance, P hat, which is 0.75. So if we are going to find the population proportion, then we need an interval in between this value has to occur. So what is the interval? Maybe it is 0.74 or maybe it is zero point 0.8. But 0.75, we just approximate that, okay, for entire population, it has to be in between this interval. So point estimation is this. By using this point estimation, you need to find an interval in which the population proportion has to occur or it will occur in that range. So if we take the confidence interval, so confidence interval is giving you the range of numbers in which we can expect the population proportion has to occur in that range. So sample proportion is 0.75. So what is the range for the population proportion by using this estimated value that population proportion has to occur in that number of range values? This is what we need to know. So if we are talking about confidence interval, so confidence interval is giving you the range of numbers. Remember, it is interval. Interval means we are talking about the range of values. We are talking about the interval means the range of values in between the population proportion has to occur in that interval. So this is what confidence interval means. Confidence means you are very confident that the value has to be occurred in that. So this is why we are calling it confidence interval. You can symbolize it that way. So confidence, this is what it means. And the definition of the confidence level is confidence level. What is the level that, or how confident you are that the confidence interval actually contains the population parameter or what you are looking for, like P in our case, how accurate you are that confidence interval contains P in that. So for instance, in this example, if I am taking 0.74 and zero point 0.8, this is the interval, how likely that 75 number of students or 76 number of students or 79 number of students are not getting flu after having a shot. This is what all it means, that how accurate you are, how confident you are that the confidence interval contains the population parameter. And in our case, this parameter is proportion we are going to find out, like percentage of students who are not getting a flu after having a shot. So if we are writing it symbolically, so this is 1 minus alpha here. You know, in probability, in terms of probability, 0 means uncertain and 1 means certain. So how likely you are sure that the confidence level is containing, that the confidence interval is containing the value of P. So this is 1 minus alpha. So it means alpha is the complement of confidence level. If we're taking it out, that is giving us the confidence level. So alpha is the complement of confidence level. So then this range is telling you, or percentage, it will be telling you how accurate you are in finding your confidence interval that is containing the value of the P. So the most often we are using the confidence um interval, the most often the confidence level will be zero point 0.9 90% or 0.95 which is 95% or 0.99 99%. So if you are taking the complement of these confidence level, so alpha will be zero point 0.1, so it means 10%. It means if 90% are certain, like 90% you are sure that the confidence interval is going containing the value of the p, then 10% chances then it will not be containing the value, because alpha is the complement of the confidence level. So confidence level is 90%, then complement of confidence level is 10%. So in terms of portion, in terms of decimal values, if you will be writing it down, then alpha is 0.10. 95% you are sure, then 5% that you are not sure that the confidence interval will contain the value of the population parameter or P, which is 0.05. 99%, if you are sure, then 1% you are not sure that it will be containing the value. So alpha is the complement of the confidence level. For example, the 95% confidence interval, if you are going to find out 95% confidence level for P, probability that the short will be successful for any single student selected at random from Mid-Michigan students. So what is the range you are going to find out? Because P is the proportion. What was P hat in our case? In the same example, P hat was 0.75. If you are 95% sure, so what is alpha in that, which is 0.05? So P hat was 0.75. So alpha is 0.05 if you are 95% confident. So it means your range will be zero point 0.7 to zero point 0.8. You are subtracting and adding alpha from this value to find the interval. We are discussing it in a bit. I know it's a little bit confusing, but when we are going to the examples, then it will be more clear to you that what does it mean, what alpha is, and what is the confidence interval, what is the confidence interval. So we will be discussing it in a bit. But we are not sure that what is the actual value of P. We cannot 100% sure that, okay, if the sample, for sample, this is the statistic for the sample, then the parameter will be this, will this be for the population. We cannot be 100% accurate in our estimation for finding the value for any parameter value for the population by using the statistics. This is why there has to be a margin of any error in that. How certain you are, how likely you are correct in your estimation. So we have to build some errors in that. So in order to find those error and in order to find those bounds, we have to use the confidence intervals in this case. So what is confidence interval? Confidence interval is giving you the range of numbers in which your population parameter will contain. What is confidence level? It is telling you about how confident you are. It means how many percentage you are accurate that your confidence interval will contain the value of the P. This is what it means. But we are not sure. We don't know what is the value of P. We don't know what is the exact value of the population parameter. So this is why in this case, I'm 95% sure in this case, in this example, 95% sure I am that the value will that of P will contain in that interval, in this interval. I'm 95% sure because I have the confidence level in this case I have been given. So if I know the confidence level, then I can find how accurate I am or what is the interval there or what is the range of values we are having in between the value of P or the population parameter will occur. So in order to find the confidence number or sorry, confidence interval or the confidence level, we have to find the z-score. We have to find the critical value. What is the critical value? Critical value in our case, this is the z-score. Z-score is the critical value. You remember z-score we have discussed, which is x minus mu by sigma, which means the random variable minus mean divided by standard deviation. This is what we have discussed earlier. So z-score, that z-score is giving us the critical value. So what is the z-score? It is the number, it is actually giving you the number such that area under the normally distributed standard normal distribution curve between minus z alpha by 2 and z alpha by 2. Alpha is the complement of the confidence interval. So we have to find out what it is by using the chart. Okay, so this is uh, equals to the confidence level. So, or we can say that z-score is actually the value that's, or actually the value in the real line that separates the likely region from the unlikely region. We know one thing, that in overall case, we are using normally distributed curves. So for instance, we have the normal distribution in our all of our examples, or in all of our problems, we are taking the standard normal curve. So in this case, let's say we are 95% sure that our value is accurate, or the population parameter will contain in this range. I'm 95% sure that the population parameter or P will contain in this interval. It means it will contain in this interval. So I am 95% sure. So this means this is my 1 minus alpha. I'm 95% sure this region is the confidence level. This is confidence level. And 5% I'm not sure that the value of P will contain in this region. So it means this is our, so because the region is normally distributed, so, and 5% I'm not sure that the value will contain in this region. So it means 0.25 percent 0.25% will be, it will be distributed on the left, and 0.25% it will be distributed on the right. Then it will be making the 5%. So it means 0.25% region will contain in here, and 0.25% will contain on the right of this region. So it means this is alpha by 2, because alpha is 5%. Because if 95% you are sure that this region is containing the value of the population parameter, then 5% is the complement of that. Because this is normally distributed, so half will be on the right side and half will be on the left side. So this is why I'm writing it down alpha by 2, because alpha is the complement of the confidence interval, and alpha in this case is 5%. So 0.25 is on the left, so alpha by 2 is on the left, and alpha by 2 is on the right. And this value, this is giving you the z minus alpha by 2. This is the critical value. This is the number or the critical value that separates the likely region with the unlikely region on the left, right? So this is why I'm calling it z minus alpha by 2. And on the right, you know that we have all positive numbers of in the standard normal curve. So this value is z alpha by 2. So I'm writing it down like this. So this is the value in the standard normal curve that is separating the likely region to the unlikely region on the left side. So this is why it is called critical value in this case. So we often use critical value 99% or 95%. So what does it mean? Hold on. So if we have, for instance, this is the confidence level. Now you know that what is the confidence interval. In this case, or in this example, this is our, this region. Let me make it colored. This region is our confidence level. This is our this region contains my confidence level, that this region contains the value of the P. And the left region, this is my unlikely region. And this line is actually separating the likely region to the unlikely region. And on this line, this point is called the critical point, that is separating the likely region to the unlikely region. Uh, and this is my z-score. This is the critical value. So confidence level. So you know the green thing, the green section in this is my where is the confidence level. All the green part is containing the confidence level. So 95% is the confidence level, and alpha, which is 5%, the complement of it. So I have three things in here. I am going to write it down. Alpha, which is the complement of the confidence level, or chance of being wrong in my case. Or this is the 99% I am accurate that this confidence level contains the value of the population parameter. And alpha is the value that is not containing that the chances that I can be wrong or I am wrong, where it does not contain the value of the parameter. So it is actually the complement of confidence level, right? So if 99% is your confidence level, then alpha is, which is 1%, the complement of the confidence level. And I have to find alpha by 2. You divide it by 2. Why? Because the region is normally distributed. So half will be on your left side and half will be on your right side, the unlikely region where the population parameter does not contain in that. So this is why I have to write alpha by 2, and then I have to find the critical value z alpha by 2, right? So these things I need to know in all of our examples. So what is confidence level? Let's say your confidence level is given to you, which is 99%. So alpha, which is the complement of confidence level, it means 1% will not contain it. Or if you're writing it into portion, so it means 0.10%. If you're writing it into decimal points, so it means 0.10 level, you are not confident that this interval will contain the value of the population parameter P. So alpha by 2, you have to divide it into 2. So this is 0.05. And z alpha by 2, it means you have to find the critical value. So remember, we know the table through which we can find the value of the z-score and the area. So area is given to you. In this case, area you know, which is 0.05. And you have, from that table, you have to calculate the value of z alpha by 2 or minus alpha by 2, because it is to the left of 0. So you can also use in your calculator inverse norm, and you have to use the area. The first thing, you have to write the area, which is 0.05 to the left, and then mean, because we are taking standard normal curve, this is 0, and 1 standard deviation because you are taking standard normal curve. So when you calculate it in your calculator, inverse norm, area is 0.05, 0 and 1. When you paste it, so this value is giving you minus 1.64 up to 2 decimal place. This is minus 1.604. But when you are finding the critical point, you have to take the magnitude of it, because we are interested in all positive values in this case. So we will be taking all positive values for the critical value. So critical value, if you are finding it minus 1.64, so this means the critical value is 1.64, because all critical values you are finding is in you are finding it in positive signs. You are not taking the negative values, because it's just telling you where how likely your region is, and where it is actually separating your likely region to the unlikely region. This is why we are taking 1.64. So in short, Z alpha by 2, or the critical value, you have to take positive. No matter what sign it is there, you have to take positive only by when you are finding the confidence intervals, not in chapter 6 or chapter 7. Only in this case, chapter 8, you have to take the critical value, and you are finding only positive values for that. And if you have 95%, then complement of confidence level is 5%. It means 0.05 in decimal places. The complement of confidence level, if you are divided it by 2, then this is 0.025. So when you calculate the value it in the calculator, then this is giving you 1.96. 1.96 will be the value for inverse norm. Let me have a look. Okay, so this is 1.96, and I'm sorry, I am wrong here, because actually I take the wrong values. If it is 1%, and if you're writing it into decimal places, so this is 0.01, and this will be 0.005 when you are dividing it. So this is 0.005. So if you take the value 0.005, then this is giving you, what will be the value if you are finding it 0.005? So this is giving you 1 second, 0.005, and then you are finding the value. This is giving you minus 2.575. So, and if you round the value to 2 decimal bases, so minus 2.58, and when you are taking its norm, so the positive value will be 2.58. The rest is the correct one. And 92%, it means 8% is the complement of the confidence. If the confidence level is 92%, it means complement of confidence level is 8%. So if it is 8%, it means 0.08 when you write it down into decimal places. And it means 0.04 will be, if you divide it by 2, it will be 0.04. And when you find its critical value, so this will be 1.75. And if you are finding 90%, so it means 10%. So now you are using 0.1%, 0.10. And when you alpha by 2, you are taking, which is 0.05. Now, if you calculate, this is value 1.9, 1.64 will be the value of it, right? So this is how you have to calculate the values of alpha and alpha 2. So alpha is the complement of the confidence level. Confidence level means how accurate or how sure you are that the value of P will be containing into the confidence interval. We will be coming to that point that you have to find the confidence interval in these questions. Okay. How to compute the margin of error? So when you calculate the value of the point estimate, then you have to find the range of numbers that contains the value of the population parameter. So if you find that range by when you estimate the value of the population parameter by using the sample statistic, then how accurate you are in your prediction, how accurate you are when you find the when you're using point estimate to calculate the value of the population parameter. So it means you have a margin of error. So what is margin of error means? Margin of error means what is the maximum difference between point estimate and the population parameter for which you are interested in. In this case, we are interested in finding the population proportion. So P is the population proportion in this case, and P hat is the sample proportion of success in that case. So P hat is the point estimate, and what is the maximum amount of distance from the point estimate to the population parameter, that is giving you the margin of error. So that helps you to calculate the margin of error. So we know, as we are taking a sufficiently large number of sample space in our case, so and if we are taking sufficiently large number of sample space, then it is normally distributed in our case. So when you do that, uh, so one second. When you do that, now we have to find the margin of errors. Now we have to compute margin of errors. Where does it actually, what is the bound or what is the range of values which contains the population parameter? So for sufficiently large number of values, the the normal distributed curve is the best approximation for binomial distribution, and we are taking binomial distribution, and in this case our mean is actually P, which is the population proportion. So mean in our case, we will be using the population proportion, and the standard error is square root of PQ divided by N. I am going to discuss it in a bit, that how does it come and how we have to calculate it. So when you have to calculate the margin of error, here we will be discussing about, we will be using the language of the probability. So it means the how your confidence level, that how accurate you are in finding your the range of values which contains the value of the population parameter. So that is actually the probability, that because how accurate you are, 95% sure, you are 99% sure, you are 10% sure, you are 50% sure that your confidence interval is correct, that contains the value of the parameter. So it means in our case, we are going to find the probability for the range of values for, let's say, range of values, interval is A to B. Let's say, I don't know what is A, which contains P bar, P cap minus P less than B, and it contains the confidence level. So in when we talk about in terms in when we use the language of the probability, I don't know the values of A and B, but A and B is the range of numbers that is giving me the confidence interval which contains the confidence level. So the probability of getting this interval is telling you actually your confidence level. So in order to find that, we need to find the margin of error. So so uh, our estimation that P cap differs from P is no more than what number? What is the maximum bound for calculating P cap minus P? What is the range of values? What is the maximum difference we can go to for finding the value from P cap to P? What is an error? So we have to find that error in this case. We know, because we are using binomial distribution, right? So in binomial distribution, we know that mean is NP, if you uh, go through your chapter number 4, then it will tell you that mu is NP, the binomial distribution we have discussed earlier. If you go through that, then you know that in binomial distribution, mean is NP and your standard deviation is square root of NPQ, right? And you know, we are using normally distributed curve. In normal distribution, standard normal distribution curve, in standard normal curve, how you calculate the standard normal curve? You know that by finding the z-score, we can translate any normal curve to the standard normal curve. So what is the z-score? Z-score is x minus mean divided by standard deviation, right? And x in this case is the random number of successes, right? So because binomial distribution, it has success and failure. So P is the probability of success and Q is the probability of failure in a single trial. So X is the random sample. So what is mu in this case? So if you use these values in this case, so this will be X minus NP divided by square root of NPQ. We are using these values in that, right? So for sufficiently large number of values, n, here n is the large enough, because why we need large enough? Because by central limit theorem, it will be normally distributed. The sampling distribution will be normally distributed for the binomial distribution. So z will be 2. So we have to use some mathematical operations here. By using some algebra, we have to find the margin of error here. So in this case, let's say I am going to divide it by n by numerator and denominator. We have x minus np by square root of npq. I am dividing numerator and denominator by n, or square root of npq by n. If I'm using a little bit more algebra, so this is x by n minus p divided by square root of, can I write npq divided by n square? So in this case, x by n, x by n is the classical probability. Do you remember, if we have discussed earlier that this is the p hat definition. P hat is equal to x by n, the sample proportion of success. So x by n, substitute the values. So z is, x by n is p hat minus p divided by square root of n. So when you are calculating, this is pq by n in that case, right? So now what does it mean? It means this shows that the z-score in this case, in this kind of binomial distribution, which is normally distributed, mu is p, and standard deviation is square root of pq by n, right? Because we use normal distribution, we use binomial distributed, the mean of the binomial distribution, standard deviation of the binomial distribution into the formula of the z-score. We use some algebra, then it translated it into this formula. So it means when we are comparing it to the previous one, so this means mean is p and standard deviation is square root of pq by n. This is why I am using it, standard deviation square root of pq by n, and mean is p in this case, right? So when you find the probability, when you find the interval in between the value of the population proportion has to occur. So that means in the language of probability, because this is normally distributed curve and our confidence level lies that z, the probability is c, that z score lies in between the two intervals, the critical point I have discussed. So it means, what is the probability that my confidence level will contain into this interval? This is giving me my confidence level. And this is the same thing as I have discussed in this graph. So these are all the values of the Z in between confidence level, and confidence level it will be in between minus Z by 2 and positive Z alpha by 2. So this is why in the language of probability, I'm writing it down like this. P from Z is containing, Z is the value that is containing all the area in between minus Z alpha by 2 and Z alpha by 2. So it means it contains all the area which contains the value of the probability, by value of the population proportion. So Z in this case, what is Z in this case? So writing it down. So let me again write it in. So it means we are going to find the probability Z, which is in between Z alpha by 2 minus Z alpha by 2 and Z alpha by 2, which is the confidence level. So substituting, I am going to use the value of Z in this. So what it gives me, Z alpha by 2 less than P cap, what is the value of Z? Minus P by square root of PQ divided by N minus Z alpha by 2, which is equal to the giving you the confidence level. The probability of finding this interval is giving you the confidence level. So using some algebra, I can write it down this way. P, I can multiply it and if you have intervals, you can multiply it in the interval on all of these sides. If it is positive, if it is negative, then the equality will be changed. So I am square root of PQ by N. I'm multiplying on all sides of the inequality. So this is giving me Z alpha by 2 multiplied by PQ by N minus P cap minus P is less than Z alpha by 2 times square root of PQ by N is equal to the confidence level, right? So writing it down again. So when I will write it down again, so this is the error. In this case, this bound is giving me an error. Excuse me. Hold on. So this is because we have to find the margin of error. So Z alpha by 2 square root of PQ by N, this is my error. This is giving me an error which contains the value of P, Z alpha by 2 square root of PQ by N. This is my error in this interval, because we have to find the maximum error. I told you that when we find the value of the population proportion, it cannot be accurate. When you estimate the value of the population parameter or population proportion from the estimated value, it cannot be accurate. There should be, or there could be, a margin of error, that what could be the maximum difference to that value. Because for instance, I gave you an example that if 0.75 range, or 75% of students in Mid-Michigan College of from 800 samples are not getting a flu after getting a shot. And so what is the population proportion of Mid-Michigan of the entire college that it is not getting the flu shot? So what it will be the range? What is the maximum and minimum value it has to be, or in what range the value has to occur? So what is the, for in that case, you need to find the margin of error. So this is the maximum bound where it can contain, because maximum distance from P cap to P is greater than or less than in between these two values. And these two values, it means it is giving you an error. So E is actually positive. So this is our E. So it means if I will rewrite it down, I don't have space that much, but let me write it down here. So let's say if I will rewrite it down, so it means P will contain point estimation minus Z alpha by 2 square root of PQ by N and less than P cap plus Z alpha by 2 square root of PQ by N. Here, P is the population proportion and Q of success, and Q is the population proportion of failure that we don't know. So this is why in this case, we will use point estimate for using these values. So in our case, these values are P cap minus Z alpha by 2 times square root of P cap Q cap by N less than P cap, which is point estimate, plus Z alpha by 2 square root of P cap and Q cap divided by N. So this is my error. So it means if I add the error into the point estimation, so this is my maximum bound where the population proportion can go, or if I subtract this error from the point estimate, which is P hat, so this is the minimum bound where the value will be contained of the population parameter will be contained. So this is overall the problem we are going to do, finding the value of the population proportion by using the uh, value of the sample proportion. And value of the sample proportion is represented by P hat, and P hat is we are using it for the point estimate. So by finding the point estimate, we have to calculate the or estimate the value of the population proportion. So the maximum error uh, is Z alpha by 2, which is the critical value times square root of P hat Q hat divided by N. So in conclusion, error is Z alpha by 2 critical value square root of P hat Q hat divided by N. So this is my margin of error. Okay, so I use the next slide for writing it down, but this slide is for something else. I have we this in this slide we are telling that what kind of situations overall we will be discussing it in this chapter. Three situations we can have. One is finding the Z interval, T interval, and third is proportional interval for the population. So today's topic is overall on population proportion, which is proportional interval. So you have to find the interval where the population interval will contain by using the point estimate. And second situation will be the Z interval. You have to find the population mean by the point estimate by the sample mean, which is the point estimate for the population mean when standard deviation is known, when population sigma is population standard deviation, when population standard deviation is known and you have to find the population mean. So that means you are finding the Z interval. If this is sigma in this case, if population standard deviation is not known or it is unknown, then you have to use the sample standard deviation to find the value of the population mean. So then we will be discussing about T interval, but in today's topic, we are only discussing about proportional interval. In the next lecture, we will be discussing about Z interval and T interval when sigma is known and when sigma is unknown. So we are lucky in this case because in this chapter, we will be discussing only two things you will be asked for. One is finding the confidence interval. Again, confidence interval means you are finding the range of values in which the population mean or the population proportion will be containing. Today's topic is only about proportion. So population we have to find. If we are discussing about confidence interval, we have to find the interval in which the population proportion will contain. and then we have to do interpretation. It means you have to interpret the results by using the confidence interval in a given question. And the second question, you will be asked for finding the sample size, or because sample size sometimes will not be given to you, you will be given the confidence interval and confidence level to find the value of the sample size. So the first thing is confidence interval for proportion. So what steps you have to do? You know that error, you know the value of error, what is marginal error we computed right now. So what you have, when you are asked to find the confidence interval for proportion, these are the steps you have to follow. First step is finding P hat, Q hat, and N. It means you have to find the point estimate, which is the sample proportion. P hat is sample proportion of success, Q hat sample proportion of failure, and N is the our sample size. And secondly, you have to use the confidence level. So it means some percentage will be given to you that is giving you that how accurate it is that your value will be contained in the confidence interval. So you have to find the critical value that we have discussed in the Excel sheet, which is this one. Here we calculate the critical value by given confidence level. So second step is use the confidence level to find critical value. Third thing is when you know critical value, which is Z alpha by 2, P hat, Q hat, and N, then you have to find the marginal error. And marginal error, we just computed that how you have to calculate. Marginal error is critical value times square root of P hat, Q hat divided by N. This is our marginal error. And then by using this marginal error, you have to compute the confidence interval. And confidence interval, you know that it will maximum, what is the upper bound and maximum and lower bound. Upper bound is point estimate, adding the error, point estimate, subtracting the error is the lower amount, point estimate, adding the error is giving you the upper bound for the confidence interval. Or we can write it down like this is P plus minus E. P hat plus minus E is giving you the interval. We can write it down for the confidence interval. Or secondly, there are two methods you can calculate. One is by manually, you have to calculate, you can calculate. And the secondly, you can use the calculator. In calculator, you have a stat option. You just press the stat option, select the test, there will be a test option, press that, and then you will have to choose one proportion, one prop z int. It means one proportional z interval. Because you in the questions, you will be given for only one samples to calculate, to estimate the value of the population proportion. This is why you will be using only one proportional z interval. X is the number of successes. This is typo error. So number of successes is X, N is our sample size, and C is the confidence level. This will be given to you in your question, and you have to just substitute it, these values. But I don't want you to only just plug in the values in the formula and find the answer. No, I want you to have a proper understanding that what it has been asked, because what we are doing is in inference. We are you doing inferential statistics. We are estimating for population. We are using samples, uh, sample like sample statistics to find the population parameter. This is what we are doing, and two things we will be discussing: only averages and proportion. So these statistics we will be discussing about. So let's say first example is, in our first example, a touch therapist do 280 trials at 123 found correct identification, construct a 95% confidence interval for population proportion. So what does it mean? Touch therapist, their touch therapist means that he do some experiments and then they touch with both hands, and then you have to figure it out which hand they put on your skin. So he is doing these kind of trials 280 times. So it means our sample size is, for how many trials it has done, number of trials is 280 trials. So what is my success in this case? Because we are using binomial distributions, either true or false. So what is our success in this case? Finding the correct identification that which hand they put on. So he found 123 successes in his trials. So it means that p hat you have to calculate. So it means number of successes is 123. 123 times they found correct identifications that which hand they put on. So number of trials they have done 280. So what is our p hat? P hat is my sample proportion for successes. So sample proportion of successes, which is x by n. So it means 123 by 280. So when I calculate it, this is giving me, if I write it down for 4 decimal places, so this is giving me 0.4393. This is my p hat. So what will be the Q hat? Q hat is the sample proportion of failure. So sample proportion of failure, 1 minus P hat, it means 1 minus 0.4393 I can use. So this is giving me, what is the value? Which is 0.5607. 0.5607 up to 4 decimal places. So I know N, P, and Q. This is my first step. Second step is finding the critical value by using the confidence level. So for finding the confidence level, for finding the use the confidence level for finding the critical value, use the confidence level. You must have given confidence level. So construct a 95% confidence interval. So it means in normally distribution, this is my 95% portion it will contain. So in question, so this is 95% confidence interval. Construct a 95% confidence interval for population proportion. So for the entire population, what will be the um, proportion for the entire population that my experiment will be correct. So Z alpha by 2 you have to calculate in this case for 95%. So it means 5%, 5% is my alpha. So it means 0.05 is my alpha. So if in the given Excel sheet where it is 95% confidence level, because for construct a 95% confidence interval, so it means 95% is your confidence level. So alpha is 5%. So in decimal places, this is 0.05. Alpha by 2 will be 0.025. The reason I'm dividing it by 2, because it is normally distributed, half region will be on the right and half region will be on the left. So Z alpha by 2, we always have to take positive values. So this is 1.96. So when you calculate by using the formula, in this case, you know what is Z alpha by 2 is 1.96 is the critical value. So third step, you have to find an error. Marginal error, you know, which is Z alpha by 2 times square root of P hat Q hat by N. So what is Z alpha by 2, which is 1.96, square root of P hat 0.4393 times Q hat 0.5607 divided by sample size is 280. Now you have to find an error. So what is an error when you compute? This is giving you This is giving you 0.0581. This is an error, right? So fourth step, what you have to do, you have to find the interval, confidence interval. So confidence interval, you know, for the population proportion. So population proportion will contain in p hat minus error and p hat plus error. So p hat is, you know, 0.4393 minus error is 0.0581. It will contain the population proportion 0.4393 plus error, which is 0.0581. So this fill is giving you the value. So it means when you rewrite it, so it means population proportion, this is 0.3812 less than P less than 0.4974. This is what your answer. It means if you are constructing 95% confidence interval for the population proportion, then it will contain in between 0.3812 and 0.4974 for the population proportion in this kind of experiment where he has done 280 number of trials in which the correct is 123. So this is for the population proportion. Now, secondly, I want you to use the calculator. If you are using the calculator, what you are going to do, that you have to use the stat option. I told you how to do that. When you are finding it by using the calculator, I need an extra space. So let me use another. Let me use another paper. Okay, so what you have to do on calculator, you have to use press stat. First you have to press stat, then go test, press an option for one proportional z interval, A. You have to go stat, then press test, then go to A, which is written like one prop z interval, enter. It will be asking you the value of, I don't know it is clear or not, but this is ask you to calculate the value of x, n, and confidence level. X, n, and confidence level. So x is your number of successes, n is the number of trials, confidence level, that how confident you are, or for the how much accuracy you want to find in finding the confidence intervals. So in our case, which is 95%, substituting the values, and then it will be giving you all the values. So x is in our case, which is 123 successes. N is the number of trials, which is 280 times the touch therapist has done. And confidence level, C level, is 95%. So you have to write it into decimal places, which is 0.95. So let me see what it is giving you. Hopefully it will be the same. Then press calculate. So this is giving me an answer like this: 0.38115, 49742. This is the interval where p hat is 0.4393 up to 4 decimal places, and n is 280 tiles for this p hat and this n number of tiles. And if you see your lectures again, the back slide again, then you remember p hat we calculated x by n. So we found the same value 0.439, and the interval is the same that we have calculated because in by using the up to 4 decimal places I have calculated before manually. So my value was 0.3812 and 0.4974. So this is the same value. If you use the calculator, it is much easy, but I want you to know that how to find the values manually. So on calculator, it is very easy calculating the values of your confidence interval, but this is how you know. So what does it mean? It means 95%. The interpretation is that 95% you are accurate in finding the confidence interval. 95% confidence interval for the population proportion is in between 0.3812 and 0.4974. So this is the interpretation we are having in this case. So let's go back to our lecture, which is this one. All right. The next example is a Pew Research poll found that 871 out of 1502 United States adults surveyed said that the US must be at the forefront of the future space exploration. Estimate the true proportion of US adults who think that the US must lead future space exploration with 92% confidence. So a Pew Research is found that 871 out of 1508. It means they take the sample space of size 1502, in which 871 says that the US must be leading in the future space exploration research. So you have to estimate the overall proportion from United States of adults who think this way. So you want to, he asks you to find the 92% accuracy in your interval, finding the accurate interval in which the United States people think this way for overall all population. So the question is, find the 92% accurate range of values for the people in the United States who think that the US will lead the future space exploration. For this, we are using the sample spaces, and in sample space, we are using the point estimate. So again, step one is if you're using manually, so you have to find the sample size, which is 1502. Number of successes, this is not p hat, please be careful in that. This is number of successes, which is 871. People think this way, that US must lead for the future space exploration. So by using this X, you have to calculate the sample proportion for success, that how many portion of people from the sample space that think this way. So this is 871 by 1502. So it means 871 divided by 1502, which is 0.599 up to 4 decimal places. And if you find q hat, this is 1 minus p hat. And secondly, what you have to do, you have to find the critical value. Step 2 is finding the critical value z alpha by 2. So for 92% confidence level, so it means alpha is 8%, which is 0.08. And if you find the critical value, let's see, where is that? 92%. Accuracy level alpha is 8%, which is 0.08. Alpha by 2 is 0.04. And critical value in this case, by using inverse norm formula, 1.75. So this is, where is that? 1.75 in this case. Step 3, find the marginal error. Error is z alpha by 2 times square root of p hat q hat by n. And step 4, you have to find the interval with this 92% of accuracy. So you have to find the p hat plus minus e. This is what you have to calculate. But in calculator, it's very easy. On calculator, you have to use 1 prop z interval. First you have to press stat, then press stat. Sorry, first you have to press stat on your calculator and then go to test. After test, you have to press 1 prop z test, which is written like a something like this. It will be showing you on your screen. So press a, and then if you press a 1 prop z interval, so then it will be asking you x in this case 871, then n sample size, which is 1502, C level, how much accuracy you want, 92%. So this is 0.92 will be your C level, which is confidence level is 92%, so 0.92. Now I'm writing the values on the calculator, 871, 502, confidence interval, 92. Sorry, 1 second. So this is giving me confidence. By using these values, I'm finding the values 0.55760 0.60219. So this is interval p hat and it is given. So what does it mean? You have to do the interpretation. So it means we are 92% confident that the proportion of the United States adults who think that US must lead future space exploration, then it will be in between 0.5575 and 0.60212. So it means 95.2% we are confident that the proportion for the United States adults who think this way will be in between this range, which is 0.5575 and 0.60219 in this case. So this is the answer. In example 3, the same thing, you have to calculate the value of the confidence interval, find a 95% confidence. Sorry, what is the question? Let's see. In a poll of thousands likely voters conducted by Rasmussen report in June of 2018, 512 likely voters said that the Democratic Party is the party of identity, politics, and victimology. Find a 95% confidence interval for the true proportion of voters who feel this way. So again, what you have to use, you need n sample size. So it means 1,000 number of likely voters I'm taking, and success is how many number of people who think this way, that identity politics, that Democratic Party is the party of identity politics and victimology. So who think this way? So out 512 number of people think this way. So again, what is the confidence level we are having, which is 95%? It means 0.95 is your confidence level when you will be using this value in your calculator. So find the confidence interval, find the range of those values or likely voters who think this way from entire population. So what is the confidence level? Again, you have to press stat, then go to test, then press A1 prop Z int. And when you press that, it will be asking you the value of X and confidence level, which is given to you. So what you have to do, stat, test. This is 512X, 1000, and confidence level is 0.95. Calculate. So this is giving me 0.48102 and interval is 0.54298. This is giving me the confidence interval. So P hat is, it means P hat is X by N, that the calculator is giving you all the values. But the reason is by using these values, you found the interval and you have to interpret your result. So what is the interpretation here? That we are 95% confident that the proportion of all likely voters who feel that the Democratic Party is the party of identity politics and victimology is in between 0.48102 and 0.54298. So this is this is our prediction. This is our interpretation from this result. Example 4, I'm leaving it on you for your exercise. Do it on your calculator and also by using manually by using the steps that I have been written. So then it will be best, you can find the best approximation for these values, and then you will get a hand on it that how to do practice on these questions. If you have any problem, please let me know. Next time we will be discussing about the sample size for the population proportion and how to estimate the value of the population mean by using the sample mean. Thank you very much for today.